Is it true? Are we live again? I don't believe it. Oh, okay, cool. What's up? Sick. Okay. So, do a little bit of work. Over here to my right, left on the screen, I have my Pi cluster. So the Pi cluster has 4 Pis on it. They're all powered and interface with a network switch. They're all kind of like right next to each other, but they get lit to warm. That's the issue. I was, after putting the Pi hole on, whatever, and we can check it out. When I enter this guy, I noticed something pretty interesting. Wait for it. Oh yeah, admin. It has a temperature reporting of, right now it's 35°C, but last night I took an old PC fan and soldered a USB. I took just a cheap USB cable, cut the other end off, and now I just have like the male portion of the USB, soldered it together just so I could have some airflow over it, and that dropped it down from, I was doing some just like very basic stuff, just real simple commands on the Pi, and I saw the Pi 4 I was on got up to 75 Celsius. I was like, yikes, like it really wasn't doing anything. Physically like hot to the touch. You could touch the USB ports and it's warm. Anyways, so bigger task behind that is to I'm like halfway done, if you will. I've already built or 3D printed the rack, and then there's shrouding on the side. So the ultimate goal is to have a fan pull air through it, like suck air through the rack to cool it. I need to power off all the Pis. I could just do that easily, but I'm an engineer and I like to gold plate things. So instead, I currently have one website. It's kind of like a test environment, if you will, for an application. So I'm gonna take that. It's currently it's a Node web server, and it's serving up an Angular application. But right now it's simply a forever task, so it's just running in the background. But the problem is if the Pi powers off or something, then I'm going to lose that, and then I have to manually SSH into the Pi and restart that instance. So instead, what I would like to do is create, I want to create a Docker file and create an image and deploy that image of the web app and have it hosted that way. Additionally, I can add that like restart, what was it, until stopped or something like that. So that way if the Pi turns off or whatever reason, I don't explicitly turn off the container or like shut it down. It's gonna stay up and running, which is cool. And then lastly, I wanna put so you can port forward so many ports, and a popular one to use is like 80 or 443 for websites. But if you host multiple websites, they can't all you can't port forward to multiple things. Instead, you port forward to one thing, and then that guy internally will reroute that request to other services, whether it be on the same machine locally or to a different local or within network. Does it have to be within network? I don't know. Other devices. That way you can have many different things running with subdomains, etc. So put Nginx on as reverse proxy as well. Both of those things will be running on Docker on a Raspberry Pi 1 of all things, Model B. One of my very first Pis. I didn't even get the Pi explicitly for it. It came with my Bitcoin miner, believe it or not. But that thing now costs more to run than it's worth, so I repurposed the Pi to be a web server. And now it's going to be Nginx as well. So let's update the to-do. Where's that? Yes. Okay. So to do, can we font size this a little bit bigger? Ooh, way too big. All right, that might be all right. Might be all right. Cool. Right. So create Docker file. I think this is what we do. So if we create a Docker file, that'll contain an image, and we'll also have the ability to run any commands we need to at the beginning, which is no big deal. Maybe we need that for Docker Compose. Do we need to make a Docker Compose? I don't know. Ultimately, we want to, let's back up and do a bigger thing. We want to Dockerize, we just want to Dockerize the Node app. Okay, and then also, additionally, we want to enable restart for image, and then Nginx install proxy config. So quite a bit of stuff to do. Hopefully we can make some progress through that. Cool. Oh my god, that is atrocious. I had the window up so I couldn't see like what it looked like on the stream. Let me bring that size down a little bit. That was, wow. Okay. Maybe I can live there. Cool. Cool. Let me just do a sound check real quick. Maybe you can live there. Cool. All right. I wish I could boost my grain a little bit on the microphone. I doubt it. Sweet. Okay. Maybe I can just talk louder and not mumble as much. Did notice that in the past videos I did. Sometimes it's a little hard to hear what I was saying. Need to like go back and caption everything, but psych, that's not gonna happen. Okay, anyways. So let's see what's good. We have Docker. That's the first step. We do have Docker. Docker nothing. Cool. All right. So we want to Dockerize a Node.js web app. Hey, what a convenient web search. So let's look at that. Let's see what we need to do. We could, let's see how to, I think we need to make a Docker file. All right, so yes. All right, next step, we'll look how to run this app inside of Docker container using an official Docker image, right? So we'll use a node image. Probably use the latest, version 14. What version of Node are we on now? What version of Node do I have on the Pi? That's a better question because that's what it's running with. It should run with anything, but dash version? Never know if it's like dash V or double dash V or dash version or double dash version. It's run 11. Gross. That could be upgraded. Node 11. What version? Like, what do we have in the world? NodeJS version. See how easily I get distracted? Like, it's bad. What are we on? What's the latest? 14. Current. Recommended. Okay. Why did they skip an entire one? I don't know. Anyways, okay. So right now, if we do, I think it's forever list. Forever is an application that can run things in the background. That way it doesn't like steal your terminal session. That way it's like, you know, if you were to like disconnect your SSH, your whatever program you're running would die if it was not ran in the background. Cool. So yeah, here's a list. Hopefully, can we see this? Let me just double check. Yeah. And this guy is showing one thing running, and it's app.js, which is it's listening on port 3000. Let me get my if config. So we're running on, where's it at? Ethernet 141. So we can check this by 192.168.0.141. mess that up. .141:3000. There it is. That's the web app. We're actually going to go to welcome. There, cool. Now you can see something up. So we can keep this there. So we can leave that on port 3000, but what I want to do I want that to be on port 3000 as well. It doesn't typically matter what your port is. We can keep it 3000 for the sake of demo. But essentially I currently have, I believe in my router, open port 80, and it's forward porting to this Raspberry Pi on port 3000, hence the application is served. So instead, can we do a Docker images? Is that a thing? Oh, look, I already have Nginx here. How do you update an image? I was playing around with it one time. Docker image update. Let's just be more specific. Nginx. Container reload? Find your container name, reload, etc. You can directly access. And what does that mean? What it was reload? What does that even do? Container. Get latest image. Lastest. Whatever, it gets the point. Yeah, how do you do that? How do you pull latest image? Docker pull Nginx? Maybe? Let's try it. Docker pull Nginx. Ooh. Bomb diggity. This is a Pi 1, so it is very slow. Oh yeah, I don't know if I finished rambling. So while this is doing its thing, right, so I have to power off the entire Pi rack, and when I power it back on, because currently the website's on a background task, I'd have to manually go in and restart it. So now I want to make it to where if I power off the Pi, when I just plug it in, I don't have to do anything. It'll just turn on and start running the applications it needs to run. What I'm curious, Raspberry Pi, interesting. Model comparison, model B. We're on model B, but what I want is like a giant overview. Perfect. Okay, so we are rocking. Oof, we gotta scroll. This guy on the far right. Woof. $35 still. Why is he $35? Are you serious? Get out of here. But I want to know what my Ethernet. Aha. We don't know. So what is this? This could be bad. Raspberry Pi B. Ethernet speeds, but I just want like straight up B. Can I do 2015 up in there? You can get gigabit networking on any current Pi. I don't know. TLDR, I don't know. Original Pi networking speed. Let's just do that. Original Pi networking speed. Oh, look at that spelling. It's bad. It's bad. Ah! Almost done. I don't know what's good. What is the Pi temperature thing? Let's look at the Pi hole. Let's refresh that. It's 35.4. I don't know if you can see that. That's the one on the very top. We're gonna see what the current Pi is once this process is done, pi temperature command. Yes. Okay, almost done here. Grabbing the new guy. I know what a smart person would have been doing. Just trying to figure out how to Dockerize this thing. So we're going to create a Docker file. Okay. And then it's okay. We're still creating the Docker file here. Package.json. It's a little bit different because we're going to be running an already deployed application, so we don't need to copy the package JSON. Package modules. Yeah. Or do we? No, everything's already good to go. We just need to copy the oh yeah, we're going to mount a specific directory locally for this guy to use. That way I can drag and drop the deployment from this current desktop that I'm on, and hopefully the thing will see the new files. That's well, it's a little bit of a stretch to try to do. I think it'll work. I think if I mount a specific directory, I can just update that, and hopefully Node within the container will get those changes. Here's hoping. Alright, so expose. So here's the whole thing. Okay, so we can use something similar. Docker ignore, that's fine. So we want to build the image. So go directly to your Docker file. Oh, the directory that has your Docker file, right. Run the build command, build the Docker image. The T flag lets you tag your image so it's easier to find later using the name, your username. We can do that. I thought, hello world, I thought I had a username. Can we see what we're currently logged into? Docker get user ID. Docker ID accounts? Yeah, I thought I pushed to that, didn't I? You cannot log in with your Docker ID until you verify your email address. Docker login is a thing. I don't know if I want to log in, all that stuff. Nah. Later. Cool. So we'll keep this. Wait for this thing to finish updating. Wow, that is very slow. Slightly concerning. The app runs fine, so I don't have any worries about that. But that took about a year and a half. Okay, right. Do we still have that thing on our... Yeah, we do. 33. See, check that out. Ice cold, baby. Baby. So once we create the image, then we can just run it. And when we run it, we'll also pass in that restart thing. So this is our exposed port, passing it down into the internal. So the exposed, we can keep it 3000, 3000 for the sake of simplicity. So, working directory. Okay, let's go to where our code is at. CD documents, I think it's dev, and then it's web server, yes, ls. Cool. So we're gonna put, I think we're gonna put the Docker file here. Okay, capital D all together, cool. Docker file exists. All right, let's go into that bad boy. Boom. In it. So let's do it. Let's do from all caps. I'm gonna write this out manually just so I can get a little bit of experience to form also memory, if you will. I'm gonna make it a common thing. So I'm gonna be playing with Docker quite a bit coming up here soon. Create an app directory. Now is this where it's gonna be running? So what happens here? We need to one, get the NodeJS server running. Moreover, the NodeJS server that is going to be running needs to be pointing to a correct directory which contains the files. So next we create a directory to hold the application code inside the image. This will be the working directory of your application. So are we're creating this directory as well, and then it is our working directory? Don't know, but we'll just whatever they got, you know. They know best. So next we are going to create a directory to hold the image. Now, is this truthful? Do these guys know what they're talking about? Are they just, what if it already exists? Source app, user source app seems pretty legit. This will be the working directory. All right, you know what? We'll keep it. User source app. Okay. We starting off. But if we just copy this crap, both package.json and package lock are copied. What if we need to make a directory? Because I don't want to just barf my code out without updating the Node application or the Node file, because it's pointing to a specific directory to look in. So if I copy the same like directory structure, it should just be plug and play, and then I can mount. That'll be number 2, I guess. Then, or maybe we can volumes. I don't know how that works. Oh, 9. This may be a lot. Try to crank out. Let's just serve the app. We want 3000 for port, so maybe I can keep the existing thing running, and we can play around on something else. Yeah, let's do that. We'll do some random port. Internally, it can be 3000. That way, the file doesn't have to change. Yeah, okay, I like that. So, what is our structure here? Documents, dev, web server. Right, so inside of Chipit, I want to copy all of this. So I need to make a directory called Chipit and then copy Chipit and place it in there. Yeah? What okay, so what else is here? Do I need anything here? Okay, so we are going to need, well, we can take that. We can take it, yeah. We are going to need package.json because we need to install some supporting packages. I agree with that. So sure, we'll take the lock as well. JSON. Oh, okay, so it puts it in the current directory. Oh, okay, cool, perfect. So additionally, I'll copy so that's where I want it to go. Do I just say copy chip it? Copy directory. Let's just make sure. Docker file copy directory in recursively? Yes. Copy files. Remove star from copy. Structure is there. The crap is this below? But what if I just need some files? Okay, but I'm trying to make a copy like this. Files, everything. Okay, so I want it to be, maybe we don't need this dot. And instead we copy everything. No, they have the slash on the other end. What? Oh, they got a slash here as well. I don't want all the files in a working directory. So maybe I could have done ./chip it. I think it's fine. From working directory, take chip it and put it into chip it. Okay, cool. I think that'll work, but let's keep that open just in case. We can close out of that. So what's next? Where were we at here? Okay, yeah. So now we can run a command. npm, can we do multiple commands? So npm install and npm run app.js. Wait a minute. What was all this crap? Bundle app source? The fuck? Where do they... Oh, command node. Oh, that's what we do, because we don't do npm run, do we? We do cmd. Last but not least, define the command to run your app using command, which defines your runtime. He'll use no... Yeah, that's right. Okay. Fine, they win. Okay, so... Alright, what is this? Nodes. Okay. This allows us to take advantage of cached Docker layers. Interesting. BitJudo has a good explanation here. Maybe we'll read into that later. Furthermore, npm CI command specified in the comments helps provide faster, reliable, reproducible builds for production environments. Okay. npm CI cached install, probably. I bet that's what it stands for. CI cached install. Yeah, I think so. That's probably a W right there. It helps provide faster, blah blah blah. To bundle your app's source code. Inside the Docker image. Use the copy instruction. Okay, we already did that. Yeah. So we copied our source code into another directory. Now we need to expose 3000. Last but not least, CMD with an array of all things. Node, do a thing. Oh, yikes. One moment, let me go grab a charger for this camera or phone. Over here trying to charge the phone, but the ports are messing up and now it only charges sometimes. And now we're at 9%, so gotta whip out the can and get the fast charger. Good? Cool. Good, yo. Okay. And then we need app.js is what it's called. Okay. So, Docker file now look like something. Create a Docker file, ignore in the same directory with the following contents. Node modules. Oh, because you're trying to copy everything though. Do we need everything? What's inside here? Ooh. Oh, we do, don't we? Yeah. We need to do that. This app.js is in there. We can take a look at it if you guys are curious. So node 14, okay. So we're gonna make it a new directory, and that's gonna be our working directory. We're gonna copy package lock and JSON normally to the working directory. Why did we use a / here but not in the other places? Huh? Anyone else freaked out about that? See, like just .. I bet it would work, but we'll keep it as is. Cool. So then we're also going to copy over our source code, and then we'll install, which will read the package JSON, install the node modules internally. We'll expose port 3000 on the container, and then we'll start the app. Okay, I like it. Control exit, save, yes, file to write, Docker file, great. Okay, but we also need what do they say? .docker ignore, sick. And inside of here we want to put do we have to, yeah, just node modules. You never know if it's like you need a slash or something until it's too late. We'll do also Lord Temp, which is a just temporary placeholder. I bought the domain Lord Griffith as a joke. And that's where like the temporary just static content is living, and then I'm just using that domain as a test server for another application I'm building. But one of the reasons for Nginx is so now I can have different subdomains and have many different web apps running, and only still use just port 80 on the router. Pretty cool. Word. Okay. Oh man, you guys fucking GitHub announced the Copilot. Now we're all gonna be jobless in 10 years. So that'll be fun. I think lower level stuff will be safe though. Because like, yeah. That shit difficult, fam. All right, what else are they ignoring? I don't have that, but we'll ignore it. I guess we should additionally look at our own directory and see what we have to ignore. We want CSS. Do we want CSS? We don't even need CSS. We're gonna copy it anyways. Did I do that copy command? Oh, I did not copy everything, did I? Ooh, that was almost a bug. I'm telling. Okay. So we want to Control X. Yes, okay. And we also need to touch back into the Docker file because after we run install, we need to, yeah, and before the actual app starts, we need to copy once more everything into everything. Yes. Cool. Control X, yes, okay. Great. Touche. Now, let's build the image. Your username. I don't know what my Docker username is. I created one. I think it's 4-eyed engineering. We'll just give it a basic name. Okay, let's do it. Oh, goodness. Docker build. What does dot mean? Here? Build here. Build the Docker file here. I bet that's what that is. With the tag of chipit dev server. It's happening. Sending Docker context to the, or sending build context to the Docker daemon. Pulling node. This could take a minute. Especially because we may be limited on bandwidth because of this model late. Like 2015? Pi came out in 2015? That's kind of so recent. Raspberry Pi first release. So like a release timeline, 2012. The first generation Raspberry Pi Model B was released in February 2012, followed by a simpler, cheaper Model A. 2014 released a board with an improved. How do I know the difference? B versus B plus. What do I have? Here we go. Here are a list of key differences. Oh, check that out. Presenting the B plus. A bum bum bum. Ooh, I don't have that many. I only have 2 USB ports. So I'm gonna say I just have the B. Sick. Where was that? Oh man. Yeah. That's it, dog. This guy. Sheesh. That's what we're working with. Dang. Look at that. Look at that web server. It's cranking out. Actually, it's not that one, is it? It's this one. Because it has an Ethernet. But doesn't have the 2. That's actually not. That's like a Pi. What is that? 4? Yeah, I don't know what the network speed on this thing is. Probably like 100 megabits or something like that. Was it 10 megabytes-ish, roughly? I don't know, something. 12.8. Cool. So I think let's look at build efficient. What did I look up? Oh, this is the cache thing. Building Docker. Yeah, can we TLDR? Man, look at this guy. Good job, David. Use the following code snippet or variation after all your app dependencies. After all of your app dependencies, but before you add your app code to the container. This way, you don't rebuild the modules each time you rebuild your container. Add package JSON, okay. Copy, temp, install, make direct. They made it direct. Oh, it's gonna fail. We'll go into the container and have a look around and see how everything's running. Okay, but we need to Docker mount volume, mount a local directory. Let's use our common lingo, and they'll correct us. Use volumes, I bet is what it is. Okay, is this what use bind mount? What's the difference? Limited functionality compared to volumes. Let's just go to volumes. That's like the same thing. What is this? Let's just give a little bit of a read. By default, all files created inside the container are stored on writable container layers, meaning that data doesn't persist. What? Oh, that means that the data doesn't persist when the container wait, what? And can be difficult to get out of the container if another process needs it. By default, all files created inside the gotcha. Okay. A little background. I can't read. That's a problem. Containers, writable layers tightly coupled to the host machine. Word. You can't easily move the data somewhere else. Correct. Writing into a container's writable layer, storage driver. Jesus. Docker has two options to manage file system. The storage driver provides a union file system with Linux kernel, blah, 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 blah. Docker has two options for containers to store files in the host machine, so that the files are persisted even after the container stops. Volumes and bind mounts. If you're running wait, I just So I copied over that chipit directory, but in addition to I want a volume to be pointing to an existing directory so it has access to it. And I don't want to have to build this thing each time. Oh my goodness. Is that what's going to happen? I have to go through all this nonsense? Bruh. Shoot myself in the face, that's what happens. Probably quicker to just transfer this over to like a faster Pi and figure it out there and then recreate it in a slower one. But it also took a decade and a half just to get Pi-hole installed. Yeah, I don't think it will. I think it'll cache an image. God, I hope so. Let's find out. Does Docker cache images? Base images? Docker build process may take some time to finish. It may download base images, copy files, blah blah blah. This is the reason why Docker build uses a cache. In this tutorial, we'll learn about the build process and when it's better to avoid the cache. Each layer contains. I think yes. Maybe they cover it. Docker images are built in layers for each layer in the infrastructure for the Docker file. Layers stack on top of each other. Yep, adding functionality incrementally. Let's see a simple Docker file and illustrate the build process. Okay, base image. The above Docker image runs a script, entry point.js. Yes. that prints the current date and time every minute and sleeps for 60 seconds. That's one way to do it. When the image builds for the first time, all 4 steps are executed. But the next time we build, the process will change. What's the next time? What step are we on? Step 1 of 8? Oh my goodness. I wonder what the temperature is. Can we still, like, can we refresh? Oh, it's a... Whoo, sheesh. Oh man, this is 100% doing something. I made a request over here, and it is struggling, to say the least. Oh man, total lockup. Dude. Maybe we put Nginx on a different Pi. Keep this on 3000, yeah? Wolf. Bro, that was... I mean, we're absolutely pegged on this Pi. It is trying its hardest to create this build. I mean, it goes to show you, I mean, stuff will still go through, but wow. Can't have a lot running on this little guy. I mean, I don't expect this Pi to be like... I think it'll be fine for Nginx hitting it. It's simply just going to redirect. Should be quick. Alright. We've downloaded everything. We got it on that little SS or SD card up in there. Let's have SD cards on all the Pis. Okay, let's read more about volumes. 17 minutes. I don't want to do that. That's a long time. So many minutes. Right type of mount. No matter which type of mount. Did I finish reading this? So the file is persistent conditions. Volumes and bind mounts. If you're running Docker on Linux, you can also use the TMPFS. Oh my goodness, carbonation. If you're running Docker on Windows, you can also use the named pipe. No matter which type of mount you choose to use, the data looks the same from within the container. It is exposed as either a directory or an individual file in the container's file system. Yeah, so we'll copy that same thing and we'll shit. What happens if you bind to an existing thing? We'll then change, okay. We'll get it running. And then we'll go make improvements. What are we doing first? We're Dockerizing the Node app. So what's happening? So it's kind of a 2-part process for this guy. So, alright, let's go and where are we at? I want to do something. Subtitle, yeah. Okay. So, the second step of this is to mount volume. Yes. Sweet. Can we cross things out? Because that would look cool. That way it looks like I've done something. Yikes. Okay, well. So a bit of work to do. Learning, discovering. These are very useful tools to use out in the wild. Yeah, what else? What's going on? Let's have a little chit chat. Oh, we could be reading more about volumes. Alright, fine. It's bad. I don't know if it's social media that's just like destroyed my mind or what. I can't stay focused. Right, okay, so we have a container. Docker area, yes. I don't, we're within the host. There is a container running file system Docker, sure. Volumes are stored in a part of the host file system, which is managed by Docker on Linux. Oh yeah? Or part of the host file system. Oh, okay, gotcha. Okay. Non-Docker processes should not modify this part of the file system. Totally agree. I'm not going to modify any part of the file system. Volumes are the best way to persist data in Docker. Can you share volumes? That'd be dope. I bet you could. Yeah, sure you could. Anywho, okay, sure. Well, let's go. Docker volume create command. Oh, is it like a specific thing? When you create a volume, it is stored within a directory on the Docker host. When you mount the volume into a container, this directory is, when you create a volume, it is stored. So, okay, can we create a volume of an existing directory? Sure, I hope so. This directory is what is mounted into the, okay, I got that. You have a volume, you can mount the volume, but first you need to create the volume. Hopefully we can create it with an existing directory. This is similar to the way that bind mounts work, except volumes are managed by Docker and are isolated from the core functionality of the host machine. I am drinking this and like getting thirstier. More thirsty? The utmost of thirsts. Cool. A given volume can be mounted into multiple containers simultaneously. Okay. There we go, sharing. When no container is using a volume, the volume is still available to Docker and is not removed automatically. You can remove the unused volumes by using Docker volume prune. I thought it said purge, and I was almost real happy. When you mount a volume, it may be named or anonymous. Anonymous volumes are not given an explicit name when they are mounted into a container. So Docker gives them a random name that is guaranteed to be unique within a given Docker host. Besides the name, named, and anonymous volumes behave the same way. Volumes also support use of volume drivers, which allow you to store your data on remote hosts or cloud providers, among other possibilities. Hey, that's pretty cool. So I bet, because I'm curious how a NAS interfaces with Docker volumes. We gonna have to figure that out eventually. Sharing data among multiple running containers. Well, isn't that cool? We almost done? Wow, this takes forever. Pull complete. Downloading, fetch. Oh no! What the fuck does that mean? Failed to register layer. Error processing tar file. What? No. Why do we... Oh. How come it can't just work? I needed space and executed. There is a built-in command to remove unused images. What's good? What's the error? Invalid tar header. That's why. Is it the image? Let's do Docker invalid tar header. NodeJS. If it didn't take a year and a half to download stupid image. Still facing issue tried with Podman. What does that even mean? I wanted to add that the issue probably occurs because of the difference in behavior std out Windows and Unix. Therefore, using the std out with... We're still just trying to pull node 14. Okay, what if we just do it re-downloads it? Problem was in the FTP Docker load processing tar file. We're not loading, we're building. I'm sad AF. Man. Yeah, what is this? But it's not a load error. Docker load error process. What does Docker load do? Load an image from a tar. Oh. Interesting. Let's go. The problem is solved. Apparently, Docker save image to followed by load will not work if the save and load are executed on different OSs. This is why the operation works on Mac but not Linux. Better option, save image to tar, Docker load image to tar. I'm just trying to pull. Maybe pulling where... Because most definitely... Invalid argument, no. Invalid tar header. When export or import. Bro. I'll do it. We don't even have Docker on here. All right. Raspberry Pi. Install Docker. What? We already have it? Oh, I think we already have it. Well, we got it now. This installs the required packages for your sick. I think we can use just like a, I don't know. I know Docker and Kubernetes are really thick. I want to get this done. Maybe not Nginx. Nginx is just like sugar on top, but I at least want to get the Docker image built, created. That way tomorrow or something I can work on 3D modeling that duct and then printing it. That way I can get that fan like kind of perma installed. I need to figure out kind of how I want to attach it and stuff, but I think it'd be cool. Kind of got the idea inspired from kind of automotive racing engineering, dealing with like radiator ducting, how to get laminar flow to stick to surfaces and fun things. Experimental falls. So aggressive. Are we up and running though? We have to run it? Yeah. Oh, I'm not in the group. It didn't work. Oh, I think I have this. Oh, let's go check the Pi one. Oh, we're almost done. So, okay, let's go to GitHub. Dangoose. Wiki. Password management. Expire and create a new one. Add Linux user. Man, why didn't it? Alright, let's do a capital P and see what happens. Yeah, exactly. It doesn't exist. User mod list. What do we got? How do we list groups? Can we just user mod -G? Let's see what's got. User mod. We just can't look. We don't know what exists. Okay, let's check the Pi 1. All right. There's Pi, install Docker. not authorized? Is that what it says? What does it say? Permission denied. Sudo group add. Okay, create the Docker group. Already exist. What am I? How do we... Oh, echo. That's what it is. Hi. Okay. You need to log out and back in. Oh. Or run this command. I would much rather just run this command. Password. Wrong. Oh, did it work? Yeah. So let's do it again. What is it? Oh my gosh. That moment when you forget your password. What? Man, what's going on? Wow. How did I forget my password to this? Whatever. Okay, this is where it failed last time, I think. No. A blind man could see that it failed in extracting the larger guy. How? Oh. How much space do I have? Maybe I don't have enough room. Raspberry Pi. Storage usage. Terminal. Check this space. That works too. Just. Okay. We can do that if it fails. Man, what's my password? I'm thinking about just copying the directory over and see if I can speed this up. I really don't want to be here all night just playing around with Docker, just doing nothing. Absolutely nothing. Let's try the 4 gig. Is it on here? Sick. Sick, dude. Look how fast that is. Are you kidding me? Done. Oh my god. Watch this. Let me pull node 14. Are you kidding me? This is what gigabit networking is for. I don't have gigabit coming in, but it can definitely pull 110, 115 megabytes a second. Downloads are complete almost. Oh man, that is. That's atrocious. We're extracting. Totally fine, aren't we? Yeah. That's not good. Let's get another instance of Pi1 going. If it can manage logging me into SSH while it's trying to unpack something. I bet I could open up another instance of this Pi4, no problem. Yeah. No issue. Still trying to log in over here. Still trying to extract one of these files. Yikes. Where are we at over here? Oh, we on the big boy already. Seconds in. Oh man, see we... Yeah. Yeah. Could at least play around with it, make sure everything's Gucci on the 4. Are we logged in yet? We're still trying to log in. Maybe we shouldn't overload it. You know what I mean? Because I'm going to have to copy the directory anyway, and I can't even like access the Pi because it's struggling, so... Oh, we're in. Huzzah. Did it fail? No, we still good. Come on, dude. That's just bad. So I guess it's unpacking stuff. It's manually going through the files. Figure this stuff out. Run a command. Let's get that disk size. I don't know what that's going to run. Did I just peg the thing even more? Oh, it's not found. Oh, that's fun. It's gotta be easy, right? DF doesn't exist. Lowercase? Down the fuck? Oh, 90. Okay, yeah, it's getting blasted over there. What are these megs? Oh, -H is human readable. That is not human readable. Available? Oh. I don't have enough space. What do I got over here? Gigs. Well, that's why. What? Sucks. It's all effort, nothing. Okay, well, let's go ahead and get Nginx as well. Man, look at that. Holy smokes. Well, if we run this again, that's interesting. Oh man, there's just that just doesn't even exist. There's just not that much space available. Yeah, it's gonna fail. Fuck. Okay. Should we just cancel it? Let's just, yeah, clap out. Can't even cancel it. That's dope. So, did it work? No, still being pegged. Okay, what about now? Yeah, I just don't have enough space left. Well, I didn't even think that was going to be an issue. Even remotely think about that. Alright, so let me pull up FileZilla. Let me grab that entire directory, throw it into a temp place. Right. So let me share that window. Add new window capture. New source. Zilla. Add source. Where are we at? Okay, that's what I'm vibing with right now. Right, okay, so let me create just a directory locally just to dump this stuff in. Let's do desktop real quick, just to make it simple. I'll call it pytemp. Okay, so we're gonna come up here. Let's refresh. Oh, you know what? Development might be easier. Let's cut this guy. Cuts. Oh, okay. Do we know nothing with pies? Are we here? Do we have it? Where them peas at, bro? How do you refresh? Am I retarded? Yo, how do you refresh? Oh, what is this? Refresh, yeah. There it is. Got it. Winning. Alright, so then documents, dev. Let me just copy everything. So we'll copy. What is in config? Oh. We don't need that. Maybe. I don't know. We can always add it later. Okay. We'll grab everything. But node modules. Yeah. Okay. Ripping that out of there. Alright. So we're gonna connect to the Pi. Where are we at? 4? Sure. If config. And make up some ground now. We're on 138. Probably don't have that. Host 192.168.0.138. Username pi, password. Port 22. Okay. Cool, we're in. Alright, so let's go documents, let's create directory called dev/web server. Okay. So we have there, we're inside of here. Let's copy everything and dump. Sweet. So now we come over here. We can cd documents dev web server. Cool. ls. There we are. Moreover, we can run that command we had on the Pi 1, which was build. Copy. Paste. Atrociously fast. This may take a few seconds. Oh, right. Let's close out of this. I think we're done. Cool. Uh-oh, what does that mean? Sweet. Let's see, Docker images. Ship a dev server. There it is. Okay. So we can remove that. Forget about it. I don't know what that is. But here. Now we can move. Goodness, that was atrociously slow. I need to figure out what I can delete on that first Pi, so I can at least recreate the stuff and run it over there with enough space. Is the server still working? Yeah. Okay. So it's still serving that previous application. That's fine. Right. So let's continue. We'll run the image on a random port. Redirects a public port. Oh, it's just P. Yeah, you define your port. Detached. You can Docker PS. You can log inside. Okay. So let's run it. Docker run. Oh, it works. That's cool. Ship it server. P. Let's go. Just so we know the port thing's working, let's go like 1, 2, 3, 4, 5. 1, 2. Let's do like, I don't know, 69, 69. Perfect. Map it to port 3000 because that's what's exposed. We'll run it detached. Oh. .p 6969 3000 is what is exposed from detached, and then here we'll do ship it server. Cool. Sweet. So now if we open up guy here and do 192.168.0.138 6969, we're in. Sweet. That's good. We've now Dockerized our application. Okay. This is app.js. So currently we're looking at this particular directory. Anything, grab the index. Everything else, look for chip bit. Okay. So it works. Port 3000. Cool. Let's see about running Nginx. Yeah. Nginx, Docker, Raspberry Pi, it doesn't really matter. Maybe like a quick start here. Yeah, okay. Name. Oh, because that's our process. So if we do Docker PS, we're gonna get like just nasty. But if we give it a name, Container, I think that changes our container ID, maybe? Alright, 8080 to port 80 on the inside. That's fair. Exposing... Yeah, okay, that's fair. So if we do docker run, let's just see what happens. Name... Oh, let's blow this up. Says the terrorist. Expose, yeah, we want to expose an external port. Some Nginx. Bad naming, but whatever. And then we'll just do some content Nginx. We'll just Nginx. Dog. But I was looking at the wrong line. Ha 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 ha. Fear not. We'll map it 8080 colon 80 as well. Yeah. So now if we do dockers, let's see what's good. So what does the name do? Oh. Yeah, no, what does it do? I don't understand. But we can test to see if it works. Go to 8080. Welcome to Nginx. Hooray! Now, let's go look up Nginx reverse proxy. I don't know if it just works, if we can just like switch our live app over, so we can try it out. Fuck something up though. Know what I mean, dude? Right. Let's get a time check. 10:30, not bad. Okay. I think it's cool that we got it running in both places, huh? Word. So, oh, we could do the volume as well. Let me open up another window. I'm gonna go to my router. I'm gonna change the live port to this guy and see if it even works. I think it'll be okay. Let me go to advanced. So right now it's on. Okay, so let me edit this guy. Port 80, 38, support 6969, save. Okay, theoretically now, if I go to Lord Griffith, rejected request from, what does that mean? Forbidden request, oh no. You're trying to reach TRP's public address from a device which is already connected. What did I do? I don't think I can do this. Yeah, you have to port forward on your router. Your router should be dropping unsolicited packets from the internet. If I refresh. Well, got Angular. Oh. What? So let me. How do I know if it's working? Okay. So I need to know that it's going to this new Pi. I'm going to open up DevTools and empty cache and reload. I'm going to watch. Yeah. Okay. I saw the networking light trigger. Yeah. Okay. Cool. So there we go. We have switched over. We're now serving. At least we're hitting the Docker container directly. Now we need to forward to 8080 on that same guy to go through Nginx. So let's update our to-do. What did we do? We need to, so we have Dockerized. We have Dockerized the node out. We need to mount the volume. We've installed Nginx. It took like half a second. Oh my gosh, this box is so small. And we need to do proxy config. Okay. So let's stay focused and let's enable mounting a volume. What is this? How to use Nginx? Oh, I think we already did that, yeah. Complex configuration. Look at me trying to stay focused. I'm already looking at like reverse proxy stuff. Out of the box, Nginx doesn't support environment variables. I don't care. Where's the reverse proxy? Did I miss it? Is it here? I don't know. We'll look at Nginx explicitly. What is this? Oh yeah, the temperature. Let's see what the temperature is. Fuck it. Nothing. Breezy. Easy breezy. Additionally, not even sweating. I have K3S going. Yeah. I need to just like not have that. Ideally, these Docker container or these images, whatever, will be with inside Kubernetes. And Kubernetes itself will be the ingress controller, which will handle the reverse proxy and stuff, and then forward that traffic to the right container instance. All that will be managed. That'll be later, though. Okay, so let's see what we got going here. So we need to get a volume. Choose the, in general, the biggest difference is that V, okay, so we'd have to explicitly define this every time unless we made a Docker compose file. Then we'd just run Docker compose, which would do everything for us. But in our case, what if we, okay, if we, hear me out. How do you stop? Docker stop 2C06. Is that a thing? Seems to be doing something. Right. So now going to, it's not this one. If we change this to, stop it. Actually, we can just, if I can go here, that should fail. Perfect. Okay, so now if we, let's modify the Docker file so that we can test to see if this guy, how do you comment something out? Is it this? Docker file comments. Yes. So this will not copy the chipit directory, and it should fail. Let's verify this. So we'll do everything but have content. The application should break. Yes, Docker, okay. If we run this guy again, oh, we gotta build the file. Let's see how fast it is to rebuild. Oh, I see why they... I see why they... Okay. I gotcha. I see why they tell you to do that. Because it stacks on top of each other. How do you uncut? Shit. Okay. So Control X, yes, okay. Let's do that again. Much faster. Sick. Let's spin that thing up. What is that? What? Oh, those are all on 69. What the fuck? So can we Docker stop? Let's do 1C28. Oh no. Is this working? Oh, it is working. Oh. What is this stuff? Those are my images. I want to... Oh, okay, I gotcha. I need to update an image. What are these other things? I feel it... Oh my goodness, what the heck? For AF 10. That's not what I wanted to do. How do you rebuild an image? Did I not rebuild it correctly? Docker rebuild an image. Docker images. I have two that say none. Docker. Oh, we learned how to do this, right? Docker prune or something. How do you remove an image? Docker image remove. Then can I just put the ID in there? So like what 1C28A? Oh no. Okay, no, we're good. We're good. Let's do the same thing, but for E5E5. Image is being used by stopped container. Oh, we need to remove the container then? Okay, well let's remove 968. That's what happened. I didn't remove the old one. Docker ps -a. Docker. So what are these? Are containers? Docker container prune. Remove all stop containers. Let's do that. Docker container prune. Do you want to remove all stop containers? I think so. Hello world. Yeah. Yes. Okay. Now let's go remove these guys again. Okay. And then this guy. Sick. Now we should be able to build back into the same guy. But if we remove an image, yeah, I don't fully understand it. Now, if we run this guy, should be alright, yeah? Cool. Now, let's stop this guy. Docker ps Docker stop 1C59. Okay. Now I want to mount the directory. Oh wait, shit, it still worked. Oh, because it copied everything. I need to update the Docker ignore for my test. Fuck. How do you rebuild an image? That didn't. Docker build. I get it, but what's like the best practice? How to force Docker to clean build of an image? We'll try the force command. Okay, so we need to, anyways, let's nano the .docker ignore, and let's add chip it. Because if we ls, we'll see we have directory chip it. We don't want that, so let's rebuild the image. -f chip it nothing. God damn it. I don't want to have to like that's so annoying. Maybe this is why Docker Compose exists. Okay. I want to rebuild that same image. You don't need to rebuild your deployment Docker on every code change. Yeah, I know, I need to do Docker Compose. I don't know Docker Compose though. Maybe I should learn it. Pure Docker. Basics are good before you build this other stuff. Docker cheat sheet. Volumes. Yeah. Mounts. We'll keep this open. Docker rebuild an image. Why does Docker rebuild an image? Simply restarting container doesn't. When the image was rebuilt. Therefore, rebuilding and restarting isn't enough. I thought containers worked like service. Stopping the service, do your changes, restart it. That was my biggest mistake. Because containers are permanent, you have to remove them. Using Docker remove container name. Okay, container name. So we can do, okay, Docker, that's not terrible. It is terrible if we'd spell it out, goddammit. Such container. Oh, container name. After container is removed, you can't simply you have to run it. Containers should be independent. No, I want images. I thought we were talking about images here, not containers. Rebuilding your Docker Compose. Oh my god. For building containers. Fine. Okay, wait. Motherfuck. Alright. Docker PS. Docker PS dash all. I want everything. Docker image prune. Yes. Docker images. Docker image remove 25 FD. The image is being used by stop container. I thought we removed the stop container. Try again. What? The fuck did I just do over here? Oh. This needs to be container. There we are. Okay. Got it. Cool. Now we can rebuild. Jesus Christ. Now when we rebuild, it won't copy the chip it thing. Yeah. So this is building with the image. Cool. And we should be able to run right after this. And it should not work. Let's verify. Oh, you've duplicated that. Oh, you know what? It's not gonna work anyways. It's not running. But if we do run it, no such file or directory, chip it. Perfect. It doesn't work. Now, let's Docker PS everything. Docker stop 462C. Okay, wait for that to stop. We'll refresh the web page, make sure it's stopped. Okay, good. Let's get everything again. Docker container prune. Yes, okay. Now if we run, now we can mount a directory. What I'm thinking is now, if we do this, we can update the files within real time. We don't gotta do all this rebuilding nonsense. Just drag and drop. Good to go. Or -v my volume. Yeah, let's do it that way. So run all this nonsense. We're gonna do. Okay, that's fine. We'll do -v here. -v. Chip it. See if it works. Such file or directory. App ship it down. All right, so let's get that container ID. Let's docker exec into it. 8b28. Oh. I don't know. What do I want to do? How do you docker exec into container? IT? What does that do? Interactive TTY? The fuck? Alright, we'll exec it. I ain't even mad. I gave it 2 arguments. Oh, bin bash. Shit. Okay, so that did not work. Let's stop that guy. Maybe 2.8. Let's try again. And we're close though. So what's good? What do we mess up? Chip it, chip it. Slash chip it? I don't know. What's good? You know what I'm saying? $20 FB. We're learning. That's what it's about. Where is it? Why can't I find volume? Use v volume. Separate. The fields must be the meaning. Okay. In case of name volumes, the first field must be the name of the volume in unique on a given host machine for anonymous volume, blah, blah, blah. Second, mount type volume. Oh. The second field is the path where the file or directory are mounted in the container. The third field is optional. Okay, so let's try this. Let's exit. I think what we need to do, let's stop. Let's stop 20 FB. And let's go back here. What is the guy called? User source app. Okay, let's try this /chipit, because maybe our current working directory is not quite the best, huh? Nothing. Did it at least work? Can we exec into it? 8do3, 8do3. It's there. Okay. Can we cd chip it? Oh, we need to recursively. What the fuck? Did that just wipe everything? So we need to mount an existing directory. Or is that a file? What's inside? Good God. Is it still there? Chip it's there. Alright. ls chip it. Okay, still exists. I need to mount an existing directory. Maybe it didn't know. Okay. Maybe that's why. So we're gonna stop 8do3, 8do3. Bro, we burning it. It's good for it. It needs to be exercised. Just 11. Kind of having fun. I'm learning though. So we stopped it. So let's run this guy. So now let's say let's grab our local chip it. Okay. What's up? Is it working? Ah, come on. Fuck. 2AC8. Nothing's in there. Motherfuck. So maybe volumes, it says like, topic discussed, so types always volume, source them out for anonymous volumes, blah blah blah, destination. So we need to create a volume. Unlike bind mount, you can create and manage volumes outside the scope of any container. Difference between -v and mounts. As opposed to bind mounts, all options for volumes are available for both mounts and v flags. Okay, so if we do type, what is okay, hold up. What is order bind mounts? Maybe that's what we need. In general, bind mounts been around. Okay, bind mounts have limited functionality compared. When you use bind mount or file or directory on the host machine, is mounted into the container. The file or directory is referenced by absolute path on the host machine. By contrast, a new directory is created within Docker's storage directory on the host machine. Okay, Docker manages the directory. Okay. The file or directory does not need to exist on the Docker host already. It is created on demand if it does not exist. Are very performant, but they rely on the host machine's file system having a specific directory structure available. If you are developing a new Docker application, consider using named volumes instead. You can't use Docker CLI commands to directly manage bind mount. But I want to bind mount, I think. Docker-v bind mount. You don't have to know what the files and the containers will have to be when you build it, and it allows you to determine those files when you run it. Cool. Mount, type, source, good God. Target. Okay, so we stopped it. Let's we might have to, good fucking Christ. Type equals bind. Okay, it crashed. That's good. So then we'll do source is equal to there, and then comma target is equal to that guy. Okay, here we go. High hopes. Application is it failed. Response from Damon. OCI runtime create failed, invalid mount destination bind source chip it bind mount destination source not absolute. Okay. So let's follow the fucking directions verbatim, since they seem to know best. Fuck's up. I think we need the current working directory. Ugh. No? Still? Okay. Type bind. Okay, yes. Source volume. Oh, good God. Var lib docker volumes data option. Oof. Can we. What the fuck? HomePy documents. Deb web server. Chip it. Yes. Target. Right. What the fuck? Docker. I fucked something up. The only thing I see that's different is they have mount. -- mount. Don't think that'll make a difference, but you never know. Oh, it did make a difference. What the fuck? Hey, let me guess. It's gonna work. Cool. Cool. Okay, so now if we let ls, we do have an index.html here. Fuck. I want to see if I can change the chipit directory directly and see if it's reflected real time. Yeah. Oh, we could do that with FileZilla, no? Just move the crap out somewhere. I think so. Yeah, let's just do that. See if it works. So we're going to change the directory structure. That's just quicker with GUI, so we're just going to do that. Dev server chipit. I'm going to take everything in here and cut it. No, first off, scroll down. How do we create new directory? Chipit, we're going to call it temp. I'm going to take everything but temp, move it inside of temp. Cool. Now if I refresh, fuck yeah. Yes. That's what I'm talking about, baby. So let me barf everything back out. Fuck. Shit. Woohoo! Okay, cool. Awesome. Perfect. Exactly what I wanted. Now the volume is now real time, meaning that whatever is on my Pi, the host source, I can manipulate, move, transfer files, whatever real time, and the container is going to see that. That's awesome. Now I might need to look into volumes because that seems to be the more appropriate way to go, but I think volumes are kind of like a way to create a place, let the apps put stuff in it. I don't know about existing directories or manipulating all that stuff. As opposed to bind mounts, all options are okay. Storage overview. What's the difference? What's good? Have limited functionality compared to volumes. When you use a bind mount, a file or directory on the host machine is mounted into a container. Yes. What is a volume? Create, managed by Docker. You can create a volume explicitly using, okay, or Docker can create volume during, okay. When you create a volume, it is stored within the Docker host. We got that. When you mount the volume, okay, yes. A given volume can be mounted, okay. When you mount a volume, it may be named or anonymous, blah, blah. Okay, bind mounts. When you use a bind mount, a file or directory on the host machine is mounted into the container. That's what we used. We're good to go. The file or directory is referenced by its full path on the host machine. The file or directory does not need to exist on Docker host already. We're good. Bind mounts allow access to sensitive files. Yeah, that's fine. Yeah, I mean, obviously it's very exposed, but it is what it is. Okay, now we need to go to, what did we do? We did something. Subtitle. Mount volume. We did that. Enable restart for image. We can do that. Moreover, what I want to do is I want to stop our process. Stop. What are we running? Okay, we don't need FileZilla anymore. Close out of that. Oh no. we'll stop. CD74. Okay. And we'll prune as well. But we need to do the, if we go back, what was it? Pi hole Raspberry Pi. I think we can just go to piehole.net, Docker install. Quick start, yeah, okay, and it's, here's an equivalent Docker run script, which is what we want. -- restart, unless stopped. Copy that guy. So we want to do the same thing. We want to run this guy, bam. Additionally, we'll put it right before the mount. Right here is good. Paste. Okay. And she's up. Chip it, chip it. You're right, it does not work. Why? Oh, gotcha. Now she's up. Okay. And she's up. Sweet. What I want to do is copy that command. We're gonna put this in the Docker file for like references. We'll put it just down here. Yes. Okay. Let's cat just to make sure it's there. Cool. Sweet. Cool. Docker PS. Let's see what all we have available. Even the okay. So we'll do Docker container prune. All stopped. Yes. Bytes? It's not much space at all. We're still up and running? Fuck yeah, we are. Okay. So, man. Enable restart for an image. Cool. Did that. Looking good. What else? 2 hours here. 2:15. Let's see about Nginx let's get a reverse proxy going. Let's clean up some stuff. How to create. We did that. We tested that out pretty well. Now you can call your app using curl. The fuck? Oh, gotcha. Oh, that's weird. Don't trust that. Sweet. Good job, Nginx. Oh, what is this? No, a node. Okay, cool. Yeah. Nice. Okay. Is this guy still running? I think so. Yep. I'll need to make a Docker compose, enable caching and stuff, make it easier as well. Need to get my hands familiar with that. This was good. This was a good exercise. Learned how to mount a live directory, got the Docker up and running, figured out had space issues on the first Pi. It's good. Not bad. So let's take this guy here and let's do Nginx proxy setup. Reverse proxy. Okay. There's gonna be some sort of file we're editing. Oh my god, what the fuck? Okay, what file is this in? ECT Nginx sites available. Okay, so what do we got going? What's up and running? Sweet. So let's exec into it. We're gonna exec into the Docker instance of Nginx b71c. Here we are. We in it. cd ect dot Nginx. We're going. Is it? God damn it. Okay. Docker. Proxy config Docker. Whoa. Boot dev bin ect. Let's just cd ect. It's right there. Oh. Slash So it was right. Where were we at? This guy? All the way down to like wherever. Sites available. Config.d. Is that where we at? Nginx config? Which one? Is a directory. Let's do. What is this? Wow. Wow. I don't think this is it. Proxy setup. Docker. How to deploy Nginx proxy on a Docker. Yes. Alright. This looks like the same site I was just at. Just a bit easier. Okay. Volumes. Mounting a volume. That's fine. Should we mount a volume as well? Maybe this is a chance to play with Nginx. Docker Compose. Yeah, I think we're gonna do that. Website 1, Nano. What is this? Create a second sample website. Oh, okay. Why would you have two? Oh, directory with it. Creating another one. Jesus. What is this? It also copies a number of files. Let me sit down. Okay. Oh, that's refreshing. Do we have to do all this? How come we can't just like straight up go into where the ish is? You know what I mean? What is all this stuff? So what if we cd into conf, because that was a directory. Default conf. All right, what's good? Oh look, default conf. That's a thing. Oh, this is such a thing. Server name. Bro, I know I just need to edit these files. That's all I want to know. Server, okay. So you can define just multiple servers here? Is that what's going on? Another server. Oh my god, what the fuck? You should add a, maybe we should follow this thing. Everyone seems to be having Docker composes. Why? First of all, you should add a new service to your Docker compose file. You can call it whatever you prefer. Reverse. Chosen reverse. Here I've chosen Nginx as the image. Okay, however, in production environment, it's a good idea to specify a version. Yes. Then you should volume bind 2 folders. Path to your config, path to your certs. I don't have certs. For sure. Path to your config. What config? Next, you have to, in the configure folder, let's just configure it. Changing to a directory. Yep. Default. Go ahead and delete that. What? Oh. Upstream plex, so we can name it whatever. Open the file and then how about, you know what, okay, this looks a lot easier to manage, but still, directory, what even is this? Oh my god, what the fuck? Location. What? Example.com, right. It's listening on port 80. But the actual location is somewhere else. Plex. Should we deal with this spice? Might do that another go. I just don't know what to do. I think it's got to be easy. But there's just a crap ton of information. I just want to like capture something and then go somewhere else with it. That's it. That's all I want. I figured my request is reasonable. Listen to here 80. Okay. This whole thing is called server. Can we name it whatever? I guess it just looks for, I don't know how this works. Oh my god. Bruh. Okay, by default, Nginx looks in the user shared Nginx HTML directory inside of the container for files. Is that true? Oh, it does. Look at that. How about it? Location. So this is where we can, so we listen for something. Okay, so we'll listen locally on port 6. No, we can do whatever. We're going to port 6969 locally. But we can listen for 8080. Where are we defining 8080 here? Oh, we define that Docker. Yes, but it's listening locally. Where do... Uh-huh. Goodness, I'm getting tired. This is when we should stop. I know there's things that I want. Okay, here we go. Listen on port 80. Server name. This is where the directory where your static file. I don't want to serve static files. I want to point to a different IP. Automating how to set up Docker reverse proxy. Here we go. Look at this. What is a reverse proxy? Yes, that is what a reverse proxy is. This is the last step. The last step. Yep. Lots of things coming in. Let it divide it out. Okay. In this example, Postman is a reverse proxy. What? The source is client. You're applying to it. The client makes an HTTP request to talk to your application. The client wants to see the app, so the client creates his request. Yes, behind the scenes, reverse proxy converts this request to port 8080. The client or user wants to see the API. The client creates this request API behind the scenes. Reverse proxy converts to 3000. Exactly. It's completely different service. A reverse proxy sits in front of web servers and forwards, yes. Usually implemented to increase security, performance, reliability. Sure, why not? Why Dockular? Why Dockular? Alright, this is what I want. Do I have enough information to do something here? Port, requests are coming in port 80, right. But I'm sending it to port 8080, because that's what it's running on. Maybe it should be 80. But we could leave it open, because it doesn't matter. No. Okay, so still trying to figure out how to configure the file. Yep. Here we go. My God. Alright. Have fun understanding all this. So I know there's going to be server. Okay. Listen on 80. Server name. Okay, so we can listen on 80. Server name is going to be... Oh, let's just test. Yeah. Alright. Oh shit. God damn it. In container install nano. Unable to install. Fuck. So install it. Did it work? Damn it. Install. Oh, it's installing both. Sudo? Doesn't know what sudo is. That's dope. Unable to locate package nano. Why not? Can we do it here? Just dump it here? We need to update first. Okay, we can do that. So we're inside of the Nginx container. We're updating. That's all we had to do. Update first. Follow the commands, Garrett. Let's just see if it works. Oh! That was cool. Okay, so we have a server. Deny access if patches. I don't care. How do we highlight? Mark. MA? Whoa. What the fuck is MA? Control A? Okay, that worked. So nano mark. Oh. What is M? To copy. To mark text, press Control. And up. Mark set. Cut it. Control. Press Control K. Okay. What was it? Fuck. Cool. Server name. LordGriffith.com. Listening on 80. Now, logs. So, server name. Yeah. Then we need to location. proxy pass. I think that's all we need to do. Proxy pass. Oh, there's tab delimited, space delimited. We're going to HTTP that bitch to local. It is actually local, isn't it? Localhost 6969. Yo, what the fuck? Alright, so let's just... If we hit this guy on port 8080, it should redirect us. So let's just, yes, okay. So if we just go to 192.168.0.138, 8080, yep, that was it. So we need to refresh the thing. How do you do Nginx refresh? Nginx Docker refresh. How to reload it? Yeah, this sounds great without any interrupts. Best way to reload inside Docker is to exec commands and reload. Okay, so let's Nginx. Reload inside for correct syntax. Line 9 is fucked. It's probably location. That location thing looks garbage. 2, 3, 4, 5, 6, 7, 8, 9. Sweet. Bad gateway. Nginx proxy pass. Oh yeah, okay, yeah, just / is fine. HTTP. Oh, maybe it doesn't know localhost. It should, but maybe not. Did that work? What the fuck I just did? X, yeah, okay. Let's verify it. Cool. Let's reload that bitch. Why isn't it working? Ah. proxy pass. Localhost works. Did I get my port wrong? But additionally, so if we just do 192.168.0.138.6969 welcome, we're up. Which is still local. Oh, but it's not local, is it? Proxy pass to, okay. So we gotta, it doesn't know local, because local is not a thing, yeah? I was gonna reach out to the, maybe? Should all be the same, yeah? There she is. Okay, yeah, because it was looking locally within the container, which is just wrong. Right? Do they not mention that anywhere? Let's do like Docker, Nginx, proxy pass to another container. Yeah. So they're gonna define just change the old configuration. Web. Server proxy pass. The host name must match the service found. Blah, blah. Oh, God, stop using Docker up. Okay, but just to test something, I'm going to get back into my router. Now instead of pointing directly at the container that's running the app, I'll be pointing to Nginx, and Nginx will reroute me. I'm also going to, I guess, spin up I don't know how this works, but I'm gonna try to create a different, multiple subdomains. Nginx multi-subdomain proxy. Server. Oh, they're all the fucking same thing. Okay. Yeah. Oh, well, that's copy paste, but you'd have to, let's see. Looks like it's just copy paste over and over again. Different. Okay, we can do that. All right. Not forwarding, virtual servers. So now we'll change it to port Raspberry Pi 4. We'll change it to port 8080. Save. Okay. So if we go back to now if we go to Lord Griffith welcome. Give it a moment. There it is. Haha. Sweet. Now, if we come over here and we edit that file, we should be able to, let's mark. Yeah. What is M6? I just don't understand that. What? These things at the bottom are not helpful. M6. Control 6? I don't know. Let's find out. So let's uncut text. Control U. Yeah, that's what I thought. Oh my gosh. Nano mark copy paste. Nano select copy paste. To copy the marked text, it's Alt up. Yes, yes, of course it is. Now, Alt up, because why not? Now to paste, Control U. Jesus, what is this? Okay, anyways, so we can come over here to put like different subdomain dev. Which will do the same thing. Exact same thing. Now it would accept dev in front because right now it does not. So if we go over here and do dev dot, it does nothing. Okay, so let's come over here. Yes. Save to the same thing. Verify it works. Okay. And reload. Now we can refresh. Give it a second. Oh, Garrett's real sad. That should be working. Oh, is it because it's not HTTP? What? Do I have to register each one of these things? As like, It's fine. Do I have to register each one of these things with Google so it like knows where to redirect this? It's a subdomain. Come on, just take me to the main IP address. What's good? Really? If we go back, does it work? Yes. Did I do something wrong? dev.lordgriffith.com. Uh-huh. Interesting. That won't work. Well, I don't know. Anyways, we've now Dockerized the container. It is now restart ready. And it's running. Updated my router configuration. I've installed Nginx. Have enabled the reverse proxy on Nginx. That's pretty cool. So I did everything. Okay, subtitle. Let's remove our to-do. Done. Empty. Let's get out of this thing. Alright, sick. Let's kill this guy. But we're going to need to... Oh, no. I didn't do a restart on this container. It's a file I just... Okay. Notepad. Let's get back in there. Get back inside of that. Okay. I don't think it will persist if I close it. We're gonna find out, aren't we? What is this thing? B71C. It stopped. Reverse proxy does not work anymore. Okay. Now we need to rerun this thing. Docker run Nginx. But we need that restart command. What was that? This guy? Yeah, it's restarting this stopped. Oh. So if we do Docker run Nginx, is way up here, but I have it. Here we are. Okay, Docker run some name. Proxy. Okay. Additionally, let's go. Okay. Now, so it's running, but we need to change the configs. Not to worry, I copied this stuff. But we'll need to exec into D827. We in it. Yes. Install nano so we can edit a file. Wait for that to be done. Okay. Now we'll cd into etc nginx slash config d slash that's not a directory, but we'll go here and then we'll nano into default. Okay, now we'll use what we just learned, control this thing. Now if we want to just remove it, crap. Nope, that's how you copy. No, we want to cut it. Okay. We come over here and copy some configs. Yes. Okay. Yes. So we want to verify it. Crap, what was it? Docker reload. Nginx -t. Okay. Nginx reload. Started. Refresh. We're in. Sweet. Docker ps-a. There we are. Docker container prune. Get rid of that exited guy. Alright, reclaimed 18 megabytes. It's actually quite a bit. Now we should have 2 running. Everything's working. Beautiful. Sick, dude. Alright. Woo! What an event. Got that done in like 3 hours exactly. Learned a lot. That was cool. Alright, so now I can power off the Pi. I need to go and like free up space on the Raspberry Pi 1. Just keep adding stuff to my never need to do. Speaking of to do, let's go to Trello here. Personal pipeline. Pi 1 rack. Nginx. Technically it's done. Additionally, did we Docker something? I thought I had Docker. Pi rack Docker. Yes. Done. Okay, so I'm working on doing Pi rack fan. Sweet. Cool. Yeah, not bad. Okay, what do we don't need this. Probably should have documented all this, but that's what the stream's for. Alright. Until next time.